Welcome back, students. In the previous exercise set, we focused heavily on creating and using methods, how to write reusable blocks of logic, pass parameters, and make your code cleaner and modular. Now we enter the next stage in object-oriented programming with arrays, a powerful way to store and manage collections of data. Arrays let us group similar data elements together and apply logic across them using loops and method calls. This set of exercises is designed to push your understanding of how to declare, fill, process, and analyze arrays using C#. Let's get started. Problem statement. In this task, the user is asked to enter 5 Fahrenheit temperatures. Each must be between 30 and 130. The goal is to store these temperatures in an array, check their order, if they're strictly increasing, strictly decreasing, or mixed. Finally, display the temperatures and compute the average. What you're given: a clear input constraint, 5 temperatures between 30 and 130, output rules based on the order of values. Let's begin by creating an array to store 5 integer values representing temperatures. We will use a for loop to gather these values one by one. It's important to ensure that all temperatures fall within the range of -30 to 130 degrees. If a user inputs a value outside this range, we will prompt them to enter a valid temperature again by decrementing the index. We declare our array with the line int array temperatures equal new int 5. This establishes an array of size 5. To assist with our validation, we define 2 constants, constant min equal -30 and max equal 130. Next, we utilize a loop to collect the input. The loop runs as follows: for x equals 0, x temperatures dot length plus parse x. If the input is invalid, we simply decrement x to allow the user to try again at the same index. This method of accessing and modifying the array using indices is a common and effective approach for validating data. To determine the sequence trend, we start by looping through our temperature array. For each element, we compare it with the next one. If we find that the sequence is neither strictly increasing nor decreasing, we adjust our flags accordingly. Based on these flags, we can display messages like getting warmer for an ascending trend, getting cooler for a descending trend, or it's a mixed bag if the trend is inconsistent. Next, we print all the temperatures. This process highlights key concepts like array traversal, indexing, and using conditional flags to validate the sequence. We also utilize Boolean flags for ascending and descending trends, flipping them when we detect a violation. This reinforces the idea of comparing array elements while tracking their indices. After that, we calculate the average temperature by summing the values and dividing by the total count. Finally, we ensure that all code is neatly organized, adhering to standard practices. Given 2 arrays of double values initialized at compile time, task, multiply corresponding elements, i.e., array 1 of I time array 2 of I. If one array is longer, just keep the extra values as is, store the results in a third array, then display all 3 arrays side by side. Let's explore how to work with arrays in programming. We start with 2 arrays, array 1 and array 2, which are initialized with specific values at compile time. Next, we create a third array, array 3, with a length that matches the longer of the 2 initial arrays. The method produce third array takes care of the multiplication. For the indices where both arrays have values, it multiplies those values directly. If one array is longer, the method uses 1 as a neutral multiplier for the extra elements, simply copying them over. Inside this method, a loop processes the overlapping indices, ensuring that both arrays are considered. For any index that exceeds the size of the smaller array, the longer array's value is directly copied. This approach not only demonstrates how to manage arrays of different sizes, but also shows how to create methods that can adapt to varying input lengths. Then display results shows all 3 arrays side by side, element by element. Educational concept. This task teaches how to work with arrays of different lengths, implement element-wise operations, and apply modular method design. Emphasize concepts, array length via array.length, element-wise operations using a loop, access modifier, private static, methods belong to the class and are only visible inside the class. Problem statement. This problem introduces a realistic input scenario. The user can enter any number of homework scores. The user enters homework scores one at a time, between 0 and 10. If they enter a value outside this range or a letter, they are prompted again. And we store only valid scores in an array. Input ends when the user enters -99. Task: store valid scores in an array. Discard the lowest and highest. Compute and display the average, along with those discarded scores. Display the highest and lowest score. The trimmed average. In this exercise, we will explore how to manage dynamic input sizes using arrays. We start with an initial array called numsInput, which is set to hold up to 100 user entries. The user will continue to input values until they enter -99, signaling the end of their input. Throughout this process, we will store only the valid scores and keep track of how many valid entries we have. Finally, we will transfer these valid scores into a new array, homework scores, which will be appropriately sized to accommodate only the valid entries. We validate that the input is numeric using int.tryparse, that the score is in range using checkValueRange. If both conditions are true, we accept the score. Otherwise, we ask the user to re-enter. This enforces data integrity before array storage, a key programming practice. A loop reads input until 99 is entered. Invalid inputs, less than 0 or greater than 10, are ignored. We track the number of valid scores, count, and store them in the array. After the loop ends, we copy only the valid part of the array to a new array of the exact size using a for loop. This reinforces how to slice arrays manually. Then we sort the array using array.sort scores. We compute the average starting from scores 1 to scores count 2, effectively excluding the highest and lowest values. Finally, we display all key stats: highest, last element, lowest, first element, average of the middle elements. We've utilized dedicated methods to display the highest and lowest values. This process encapsulates the full cycle of input, validation, processing, and output. Throughout this exercise set, we validated and stored structured input in arrays, compared elements to analyze sequences, and practiced array slicing and copying. We also tackled arrays of unequal lengths, sorted them using array.sort, and filtered and averaged dynamic input, emphasizing array traversal and method integration. Importantly, we structured our programs using modular methods and respected access modifiers like public static for utility functions. We applied method encapsulation for average computation, with access modifiers often being implicit, as all logic resides in main. This wraps up our exercises on arrays. You've practiced declaring, filling, and processing arrays, comparing values, and detecting trends. You've learned to combine arrays, handle mismatched lengths, and analyze data statistically through sorting and trimming. We've reinforced method use and highlighted the importance of access modifiers, especially private static, in structuring console applications. These foundational skills are essential for real-world data processing and will prepare you for our upcoming topics on classes and objects. Until next time, keep coding, asking questions, and remember to prioritize structure, logic, and syntax in your programming journey.